All right, so having written the smart function to compute the GCD of two numbers, let's see how much efficient is it. In fact, I'm going to call the same exact two numbers. Remember previously when we ran this here, it took me 96 seconds, although in a previous run was 33 seconds, which was still very, very large. So very, very large numbers to get to the GCD. Let's say instead of this naive, I run the smart function. See what happens, right? In fact, the results are startling because when I run this, the result is available in literally no time. In fact, the number is very, very, very small. So you can clearly see this is 6e minus 5, very, very small, 8e minus 5. So this is running much, much, much faster compared to what we are doing in the naive algorithm. And really, this is not a surprise. We can see this more clearly if I were to just go and put a print, for example, to print the A and B, and we can see what happens here. So I just go and say, for example, print A and say B, right? So when I run this again, this time when I run my, my smart algorithm, you realize, thanks to the smart application of Euclid's idea, you realize that the two numbers collapse really, really fast because it's like literally, building collapsing into itself types. We just keep finding the we just keep finding the remainder between the two numbers, and you see that the numbers keep collapsing really, really, really fast. So if it comes to a point where it's 30 and 10, at this point we know GCD is 10. We apply the while loop once again, this number becomes 0, and that's where the code stops and the GCD indeed becomes 10, right? So very, very impressive what has happened here. In fact, the running time has dramatically come down. And you see that this has all happened because we have used some logic in mathematics, which is making the algorithm much, much, much more efficient, making us realize that the previous algorithm was in fact doing way too much work compared to what we actually need to get the work done. And that's the whole moral of the story. You know, think of a naive algorithm, all right, that's a good place to start because that tells you what is correct, what is not correct. Try to make it optimal. Really, really quite interesting and thought provoking. I hope you found this interesting. Byte Algorithms and Olympiad Track is meant to explore algorithms in detail. Look at our website www.ybyte.in for many more such content and enjoy programming. Take care. Thank you so much. Bye bye.